So good morning to everyone. Myself M. Soundararajan, Assistant Professor from Department of Agricultural Engineering at Sri Shanmugha College of Engineering and Technology. As a part of Unit 1, we have seen physical properties of the soil in previous lecture. So in today's lecture, we're going to see elaborately two major physical properties such as soil texture and soil structure. So I have changed some correction in this slide. You can see the topic is Unit 1 Introduction and Soil Physics. In previous lectures, you might seen the topic as Introduction to Soil Physics. So that is I have changed in this slide as per curriculum and syllabus of our soil mechanics subjects of our institute. Okay, we can go into the topic. In previous lecture, we have seen different physical properties of the soil briefly and seen overview of the different physical properties of the soil. So in today's lecture, we're going to see hereafter the detailed content of the each physical properties of the soil. So as a part of that, today we're going to see soil structure. So soil structure is the permanent ratio of sand, silt and clay particles. So it determines how soil manages water, air and nutrients. So there are three as per definition. So it means the proportion of three mineral particles such as sand, silt and clay. So here the sand is the largest particle providing excellent drainage but poor water retention. The next one is the silt. Silt is a medium sized feeling smooth and offering moderate water and nutrient holding. Then last one is the clay. Clay is the smallest particle with the highest surface area, leading to slow drainage and high fertility. So clay particles generally possess the highest cation exchange capacity for nutrient retention. So soil structure triangle is used to classify soil based on the percentages of the three particles. So loam is the ideal structure, being a balanced mix that maximizes desirable characteristics. So texture cannot be easily changed by the farming practices, unlike structure. Then the management must be adapted to soil fixed structures. So management would be irrigation and fertigation. So based on the specific percentage combination of sand, silt and clay, soil samples are classified into 12 major textural classes such as loam, sandy loam, silty clay based on their percentage combination. These proportion classify soils into textural classes such as loam, sandy loam or clay, and it affects the properties like water retention, aeration, and nutrient holding capacity. So larger particles like sand feel gritty and driny quickly, while small particles like clay feel smooth when dry and sticky when wet, holding moisture and nutrients for tightly. So in next slide, we're going to see USDA textural triangle to classify the soils in different textures based on the proportion of sand, silt and clay. So in this slide, so I give the some brief about the soil structure triangle. It is a ESD soil structure triangle is the standard tool for naming soil type. So it receives the percentage of sand, silt and clay in the soil sample. These three percentages must always add up to exactly 100%. So the triangle is read using the three axes, each representing the particle type. Example, clay percentage runs horizontally. You can see the triangle in next slide. So textural classes, the interior of the triangle is divided into 12 major soil textural classes. So we can see that in next slide. That would be helpful to easily you can understand that. Yes, right side you can see the USDA triangle, textural triangle. So to find the soil name, you locate the intersection point of the three corresponding percentages. So for example, the loam zone, the refers to the central area of the triangle where the soil is balanced roughly 40% of sand, 40% of silt, and 20% of clay. So to predict the tool, the ones classify the triangle helps to predict the soil behavior like drainage rate and nutrient capacity. So clay dominance is a high in because of clay has such a large impact on the soil properties. Even small percentages of clay can drastically changes the classification. For example, from sandy loam to sandy clay loam. So for example, a soil that has the 50% of sand and 40% of silt and 10% of clay would be classified as loam. So here, let's say I give the example problem. You can for your understanding. So the you can read the problem. A soil sample contains 58%. Sand is 27. 58% of sand and 27% of silt and 1% of clay. So what is the soil structure? So now I give the step by step procedures in the solution for your understanding. So first of all, you have to find the 58% on the sand axis, which is in the bottom, and draw a line to the right. Then second procedure is the find 50% of on the clay axis, that is in left, and draw a line horizontally. Then next step is the find 27% on the silt axis, which is in the right side, and draw a line to the left. So the final line will intersect in the sandy loam category. So we can call that soil as the sandy loam. Which is this very simple method to find out the texture of the particular soil. So in this slide, you can see that how three soil separates are classified. The US Department of Agriculture, shortly we are calling it as the USDA. Uh, the the US Department of Agriculture classification system defines the three mineral separates by their diameter. So for example, sand soil has the particle size to 0.05 millimeter. There is a range of particle size of the sand of the in respect to its diameter. So it is generally gritty. Then it has the properties like high infiltration or drainage and low water nutrient retention and good aeration. The next one is the silt. It has the particle size in diameter range is the 0.05 to 0.002 millimeter. It is which is in naturally smooth and silky like floor. So it has the moderate water retention and drainage. Often it is highly fertile for the plant growth and cultivation activities. So the next one is the clay. Its particle sizes less than 0.002 millimeter. Because of its size, it influences its structure, soil structure. So it is generally in sticky or plastic when in wet condition. So it has low infiltration and drainage. It has the very high water nutrient retention due to the high surface area. The soil structure is often called the moisture variable because it controls a wide range of soil behavior and properties. So that's why the soil texture is very important because it is called master variable. It controls a wide range of soil behavior and properties like water holding capacity and drainage. So water holding capacity and drainage means sandy soils are often called light because they drain quickly the water. So while clay soils are heavy because they hold a lot of water and drain slowly. Aeration. So aeration, next one is the aeration. So aeration means the large pore spaces in sandy soils allow for good air exchange, while the tiny pores in clay soils can restrict the air, leading to water logging. The next one is the nutrient retention. So clay particles and organic matters have a high surface area, which gives the soils a high cation exchange capacity, allowing it to hold onto essential nutrients like calcium, potassium, and magnesium. So the next one is the workability. That workability means the tillage operation. Now, sand soils are easy to till Silty soils are moderately easy, and clay soils become very hard when dry and sticky plastic when wet, so making them difficult to work. So next slide we're going to see methods of determining the soil texture. So the texture can be determined using the field and laboratory method. So field method, we are using the texture by field. It is the we can right side you can see that how texture by field method has done. Then ribbon method also comes under the field method. The laboratory method, hydrometer pipette method, used for the laboratory method to find out the texture of the soil. So determining the soil structure is crucial for predicting how soil will behave, and particularly concerning water retention, drainage and nutrient availability. As the provided image shows, the texture can be determined using two main methodologies. The first one is the field method. This is the fast and qualitative method used by the farmers, agronomists and surveyors to estimate the soil structure in the field without any specialized equipment. The main principle of the field method is the test relies on the distinct physical properties of the three particle types when wet condition. So sand feels gritty and does not sticky together, and silt feels smooth, silky and flowery. Then clay soil feels sticky and can be molded into shapes or a ribbon. So I want to know, tell you the how the procedures is followed to find out the textile structure in the field method. The first one is a small soil sample is moistened and needed to break down all aggregates. The soil is pressed between the thumb and forefinger to form a ribbon. The length and quality of the ribbon determine the clay content. That means longer ribbon equal to more clay content in the soil. The soil is further tested for gritness and smoothness to narrow down the texture class using a decision flow chart. So accuracy of the field method, it provides a good estimate but is subjective and depends heavily on the operator's experience. Okay, then the next one is the laboratory method. So hydrometer pipette method are used in lab as done in the laboratory. So this is the precise and quantitative method that provides the exact percentage of sand, silt and clay for use with the soil texture triangle. The principle of the laboratory method uses Stokes' law, which states that the settling velocity of the spherical particle in the fluid is proportional to the square of its radius. Since all soil particles have different sizes, they settle at different rates. So I would like to tell the procedure followed in the laboratory method to find out the soil texture. A dried soil sample is dispersed in water, often with a chemical dispersion, to ensure all aggregates are broken down into their primary particles. The mixture is placed in a cylinder. Then the sandal settles almost immediately because that because of the size of the sand particles. Then next procedure is the amount of suspended materials is measured at specific time intervals using either a hydrometer or by removing the sample with a pipette. So based on the settling time required for particles of a certain diameter to fall below the measurement point, the percentage of silt and clay are calculated. So accuracy of the laboratory method is the most objective and precise method used for research, commercial soil testing and soil mapping. So in this slide, you can see I give the definition for soil structure for your understanding. Soil structure is the arrangement of soil particles. Soil particle means here the sand, silt and clay. So based on the arrangement of the soil particles into stable grouping called aggregates or beds. So these aggregates are bound together primarily by organic matter like humus, roots and glues produced by the soil microbes. The important term called as porosity, that the spaces within the between spaces within and between these aggregates from the pore space, which is crucial for soil function. So good structure ensures an optimum balance of air, water in the soil, allowing for proper drainage and moisture retention. So proper drainage, as seen which is seen in the macropores because it has the high void content in its volume. Then moisture retention is done at micropores because of the space is very low in the soil in that soil. So a well-structured crumbly soil provides easy pathways for root penetration, facilitating access to water and nutrients. So the pore spaces are the essential habitat for soil microbes like bacteria and fungi and fauna worms which drive nutrient cycle. So structure directly impacts the cycling and availability of the nutrients because it regulates the flow of water and supports microbial activity. Stable aggregates make the soil resistant to erosion by wind and water, protecting the valuable topsoil. So common structural types include granular, which is best for topsoil, and blocky, prismatic, and platy are often compacted. So these are some examples for structures of the soil. So soil structure is easily harmed by the compaction from heavy machinery and excessive tillage, which break down the protective aggregates. So in this slide, I give the different types of soil. Granular or come which is the rounder and small particles. So brachycyle, which is normal in shapes like cube with either sharp or rounded corners. Prismatic and columnar means rectangular shapes. The soil particles as the rectangular shapes with the prismatic having a flattened top and columnar a rounder top. And plateau means it shapes with a long horizontal dimension. So structureless, the name itself tell us that it don't have any specific structure. So soils with no aggregation, which can be single grainer like sand and or massive like compacted clay, are the example for structureless. So in next slide, we're going to see the uh, pictures of the different types of different structure of the soil particles. So with respect of the permeability of the soil particles, I have the given pictures of different soil structure in this slide. So first one is the granular, how it looks, you can see, and blocky, it has the moderate permeability because because of its structure. So permeability means here the ability of the water flowing into it. So water is flowing from higher place to lower place. It means from surface area to water table. So structure is majorly influence that water permeability. So plastic structure has the low permeability because it acts as the barrier to flow of water. So in columnar prismatic has the moderate permeability because it has the structure parallel to the flow of water, so it don't affect the permeability of the water. So an massive structure has the low permeability because it also act as platy structure to flow of water. So in this picture you can see so granular aggregated soils are high permeability and black and columnar or prismatic soils have the moderate permeability and platy and mossy structures have low permeability. So in continuation of soil structure in this slide you can see I differentiated two pores that are macropores and micropores. So macropores are generally in large size between aggregates allow to air and water to move freely and for root to grow. And the smaller spaces within aggregates retain the water for plants to use. So micropores are useful for the plant's growth as because it holds the water for plant usage. While macropores are not beneficial for the plant growth. So well-structured soil promotes aeration, water infiltration, root penetration, leading to better crop health and yield. So management is very crucial because of soil structure can be damaged by poor management techniques like compaction. Practices that add organic matter and avoid disturbing the soil are beneficial for building and maintaining the good soil structure. So, in today's lecture, we have seen soil texture and soil structure, and how it affects the plant growth and how it helps to plant growth. So, I think this is enough for today classes. In next class, we're going to see another two physical properties of the soil. I mean, major physical properties of the soil. So, thank you, students.